Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Here we are required to evaluate the orthographic projections of an oblique line in which the ends A and B, they happen to lie in the different quadrants over here. So we work out that point A of the line, it happens to lie in the quadrant 1, while the point B of the line, it lies in the quadrant number 3. Let us first of all go through the problem statement. The midpoint of the projections of the line, they lie in horizontal plane and the vertical plane. So what do we mean by this? That is, midpoint of the front view projection A dash B dash will be lying in the horizontal plane, and the midpoint of the top view projection of the line AB, that is small ab, will be lying onto the vertical plane. So it means that the midpoints of A dash, B dash and AB projections, they are going to coincide with each other onto the XY reference line. And another information we have been provided with, that is the distance between the end projectors of the line happens to be 70 millimeter, and the line, it is lying in two quadrants. That is, the end A will be lying in quadrant 1, while the end B of the line will be lying in the quadrant 3. And finally, we have been provided with the measurements of the front view projections A dash, B dash and top view projection AB over here. So the front view of the line A dash, B dash, it measures 100 millimeter, while the top view projection of the line, that is AB, it measures 120 millimeter. Now with this information, we are required to draw the orthographic projections of this oblique line, and we will be drawing the front view projections, the top view projections and the left hand side view projections of this particular line AB over here. So let us proceed with the construction of the orthographic projections of this oblique line. Now we have got the XY reference line, X1, Y1 reference line, and this special transfer line which we have drawn in such a way that it should be extending into two different quadrants over here. So whenever we are required to draw the side view into the first and third quadrants over here, so this transfer line should be penetrating into the second and the fourth quadrants at an angle of 45 degree with respect to the XY reference line. So now we know that the distance between the two end projectors of the line AB, they are separated by a distance of 70 millimeter. Here we have plotted this distance between the end projectors of the line AB as 70 millimeter. So what do we mean by this? That is, onto the first end projector, we are going to obtain the projections corresponding to the end A of the line. Onto the second projector line, we are going to obtain the projections corresponding to the end B of the line. So A dash and A will be obtained along this vertical projector line, and B dash and B projections corresponding to the point B or the end B of the line, they will be obtained onto this second vertical projector over here. And another thing we know that point A happens to lie in quadrant 1, while point B happens to lie in the quadrant number 3. So onto this vertical projector line, the front view projection will be drawn above the XY reference line, that is A dash will be drawn above the XY reference line, while the top view projection of the point A, it will be lying below the XY reference line. Whereas in this case, the second end projector, we have got the point B of the line lying in the third quadrant. So the front view B dash will be lying below the XY reference line, and the top view projection corresponding to the end B of the line, it will be lying above the XY reference line. So since both of these projectors, they are going to meet in horizontal plane and the vertical plane, that is A dash B dash midpoint will be lying onto the horizontal plane, and AB top view projection, that is midpoint, will be lying onto the vertical plane. So both of these projectors, they will be coinciding at the midpoint of this distance over here. So the total distance happens to be how much? It happens to be 70 millimeter between the two endpoints. So the distance of the projection of either end and the midpoint will also be midpoint of that. That is 35 millimeter. Therefore, this point onto the XY reference line can be referred to as M dash or M. That is corresponding to A dash B dash, M dash will be located over here, and corresponding to the plan projection AB, point M will be located over here. Now let us first of all measure the distance is equal to M dash A dash is equal to 50 mm and M dash B dash is equal to 50 mm, such that the total length of the front view projection of this line, it happens to be 100 millimeter. So if this distance A dash M dash is equal to 50, along the same orientation we are going to get M dash B dash distance also equal to 50 millimeter. So we have been able to obtain A dash B dash front view projection in such a way that the distance between the end projectors of the line, it happens to be 70 millimeter, and the midpoint of this front view projection A dash B dash, that is point M dash, it passes through the XY reference line, that is it passes through the horizontal plane. So this way the front view projections measuring 100 millimeter have been obtained into the orthographic projections over here. Similarly, we know that the top view of this line, that is AB, it measures 120 millimeter, and once again the midpoint of this line, it passes through the vertical plane. So point M, it passes through the XY reference line, because whenever the midpoint passes through the vertical plane, we are going to look at this particular projection from the top. So this point M, it will also be lying onto the XY reference line. So now with M point, that is the same point as the center, we are going to open the compass is equal to 60 millimeter, and onto this side we are going to mark point A, and onto this side we are going to mark point B, such that the distance of AM and MB should be equal to 60 millimeter each, so that this point M, it becomes the midpoint of the top view projection line, that is AB, which measures 120 millimeter. So from point M, we have opened compass is equal to 60 millimeter, marked an arc onto the first projector on this side, and marked another arc measuring 60 millimeter onto the other projector over here. So this way point A of the top view and point B of the top view has also been obtained. So the total length of the top view projection of the line and midpoint of this line, which passes through the vertical plane, so this has been obtained in the top view projections over here. Another condition has been satisfied, that is point A happens to lie in quadrant 1 and point B happens to lie in quadrant number 3. So this way we have been able to obtain the front view projections A dash B dash 100 millimeter long, which is having its midpoint M dash in the horizontal plane. Similarly, the top view projections, they measure 120 millimeter AB, and the midpoint of that projection M, it is passing through the vertical plane. So the front view projections have been obtained, the top view projections of this line, they have been obtained. Now we need to evaluate the left hand side view projections of this particular line AB, and we know that left hand side view projections will be obtained on the right hand side of the front view projections over here. So now let us proceed with evaluation of the left hand side projections of this particular line AB. Now we know that at whatever height point A dash is located with respect to the horizontal plane or with respect to the XY reference line, so at the same locus line, that is at the same height, we are going to obtain the location of the point A double dash in the side view. So what we have done, from point A dash, we have drawn a construction line or a projection line emerging from A dash such that at the same height A double dash point will be located into the profile plane. Now, whatever is the distance of the point A from the vertical plane, so this happens to be the distance of the point A in plan from the vertical plane. So this distance from the top view needs to be transferred onto the side view or profile view projections over here. So from corresponding to this point A, we are going to draw another horizontal locus line which is going to define the distance of the point A from the vertical plane. And once we extend this horizontal construction line onto this transfer line, so we will be obtaining this distance, the corresponding distance in the profile plane over here, because this angle happens to be 45 degree. So this distance corresponding to the top view has been transferred to this distance corresponding to the profile view. So if this distance happens to be x in front of the vertical plane, so here we can check the same distance x in front of the vertical plane has been obtained in the corresponding profile view over here. So from this point, we are going to take vertical projector upwards in such a way that this vertical projector will be extended to the horizontal locus line which had been drawn from the point A dash. So wherever these two projection lines they are going to intersect, this intersection point will provide us with the location of the point A double dash in the left hand side view projections over here. So again, A double dash point, it will be at the same height as that of A dash, and the distance of point A from the vertical plane has been preserved over here as we have evaluated A double dash point into the profile view projection. Similarly, in order to locate B double dash point, whatever was the location of the front view projection of the point B with respect to the horizontal plane, so here we can check point B. It is lying this much distance below the horizontal plane. So our corresponding side view projection point B double dash, it will also be lying at the same distance below the XY reference line. So we have marked this horizontal projection line or a construction line passing through the point B dash. So onto this construction line, we are going to obtain the location of the point B double dash in the profile view projection. Now we know that end B of the line AB, it is lying this much distance. Please see, this much is the distance of the point B behind the vertical plane. So this distance of point B in the top view, that is behind the vertical plane, we need to transfer into the profile view projection over here. So from point B, we are going to draw a horizontal projector line in such a way that this projector will be extended such that it meets the transfer line which had been drawn earlier over here. So the moment it intersects with this particular transfer line, so one point corresponding to the point B of the plan, it has been obtained onto the transfer line over here. And from this transfer line, what we are going to do, we are going to draw a vertical projector line in the downward direction and extend this vertical projector line till this extended vertical projector line, it intersects with the horizontal projector line which had been drawn from the point B dash over here. So this intersection will provide us with the location of B double dash. Now please check the coordinates of B double dash in the profile view. So B double dash point, it lies this distance, that is the same distance as B dash below the horizontal plane, and this was the distance of the point B behind the vertical plane. Now the moment I obtain this transfer point, so this distance, it is equal to this distance. So this distance is also the same distance as this distance, because we have marked a transfer line at an inclination of 45 degree. So it is the same distance of the point B behind the vertical plane. So this was in front of the vertical plane and this is behind the vertical plane. So point A lies in front of the vertical plane. So that is why the point A double dash was obtained in the first quadrant. So we can check this much distance above the horizontal plane, this much distance in front of the vertical plane. So point A lies in the quadrant number 1, and point B, please check B double dash. So the coordinates of B double dash, they are this much distance below the horizontal plane and this much distance it is lying behind the vertical plane. So this point happens to lie in quadrant number 3. So being able to locate A double dash and B double dash, and the moment we join, we can see this true length passes through the intersection of the XY and the X1 Y1 reference line. The midpoint of this line in the elevation will be passing through the horizontal plane, and midpoint of this line in the top view will be passing through the vertical plane. So this way we have been able to obtain the front view projections A dash, B dash, the top view projections A, B over here, and finally the left hand side view projection, that is A double dash, B double dash projections, they have also been obtained. So this is all for today. So I hope that through this discussion you would have understood about how do we evaluate orthographic projections of a line when the front view projection measurements, the top view projection measurements, and the location of the midpoint has been provided to us. Now we are going to continue with further discussion regarding few more illustrative cases of projections of the lines in the coming lectures. So thank you very much. Thanks a lot.